Now let us solve this problem here. A ray of light enters a spherical drop of water of refractive index n as shown in the figure. So you can see here a ray of light is entering a spherical drop of angle of incidence alpha phi at the front surface, and after refraction it makes an angle of alpha at the angle of incidence alpha at the back surface. All right, and the angle between the incident ray direction and the deflected ray or the emergent ray direction is delta. That's the angle of deflection. Okay, so we are asked to find out what is the angle of incidence alpha of the ray on the back surface. Okay, so what is the angle of incidence alpha on the back surface? Will the ray be totally or partially reflected? So we are asked to find out whether the ray will be totally or partially reflected. Find the expression for angle of deflection delta. Okay, what is the angle of deflection? And find the angle phi which produces minimum deflection. So for what angle phi the deflection will be minimum. All right, so here is our diagram here. Okay, and if we use the Snell's law here, okay, what is Snell's law? From Snell's law, if you use the Snell's law at the front surface, you can see the refractive index at the on the outside is 1, and the refractive index of this medium inside medium the refractive index is say n. All right, the refractive index is n. So from Snell's law you can write that 1 into sine phi, okay, that is equal to n into sine alpha. So here you can see that sine alpha is equal to 1 by n into sine phi. Okay, which means sine alpha is less than 1 by n. Sine alpha is less than 1 by n, or alpha is less than sine inverse of 1 by n. The sine inverse of 1 by n is critical angle, right? So alpha is less than critical angle. Okay, C is a critical angle. So here alpha is less than critical angle. You can see here less than the critical angle. Okay, so that means the ray which is incident on the back surface will be partially reflected. Okay, it will be partially reflected. It will not be totally reflected, but it will be partially reflected. All right, now we have to find out an expression for this delta. Okay, delta is a deflection. So if you see this triangle here, the exterior angle is alpha and the two interior angle is phi minus alpha and x. Okay, so you can see that alpha is equal to phi minus alpha. From exterior angle theorem you can see that it is phi minus alpha plus x. That means x is equal to how much? 2 alpha minus phi. Okay, this is x, and you can see here that delta, which is the deflection angle of deflection, is pi minus 2x. Pi minus 2x. So your angle of deflection delta, angle of deflection, delta is equal to pi minus 2x. Right? So when you substitute this x value here, you will get delta how much? That is equal to pi minus 4 alpha plus 2 phi. This is the value of delta, the angle of deflection. Okay, now you are asked to find out for what angle of phi. Phi is the angle angle of the incidence at the front surface. Okay, for what angle of phi is this angle of deviation deflection minimum? So for minimum deflection, if the deflection is minimum, For minimum deflection, d delta divided by d phi should be equal to 0. Okay, so if you equate this equal to 0, then you will get d alpha divided by d phi, okay, is equal to 1 by 2. You will get the relation d alpha divided by d phi is equal to 1 by 2. This is the relation you will get. Okay, d alpha divided by d phi is equal to. Now we have to find the value of phi. Okay, so how will you find the value of phi? So in order to find the value of phi, let us take the relation, that is the relation which we got here. Sine alpha is equal to 1 by n sine phi. All right, sine alpha is equal to 1 by n sine phi. So I'm going to take that relation here. All right, sine alpha is equal to 1 by n sine phi. Right, so now I'm going to differentiate this on both sides. If I'm going to differentiate on this on both sides, what I will get, cos alpha into d alpha by d phi is equal to 1 by n into cos phi. This is what you will get. And what is d alpha by d phi? Just before this we saw d alpha by d phi is 1 by 2. Okay, so d alpha by d phi is 1 by 2. So that means cos alpha by 2 is equal to 1 by n into cos phi. And what is cos alpha? Cos alpha can be written as root of 1 minus sine square alpha, right? So I can write this as 1 by 2 into root of, so this 2 I'll bring onto the other side, right? So I can write this as cos alpha is equal to 2 by n into cos phi. And what is cos alpha? Root of 1 minus sine square alpha, okay, which is equal to 2 by n into cos phi. So 1 minus sine square, root of 1 minus sine square phi is equal to 2 by n into cos phi. So I'll write this once again, 1 minus sine square, 1 minus sine square alpha is equal to 2 by n cos phi, 2 by n cos phi. And what is sine alpha? Sine alpha is 1 by n sine phi. Okay, so I can write 1 minus sine square phi divided by n square. On substituting for sine square phi and then squaring it, I will get the relation 1 minus sine square phi by n square is equal to 4 by n square into cos square phi. So I'll take this sine square phi to the other side. So it will become 1 is equal to sine square phi divided by n square plus cos square phi divided by n square plus 3 cos square phi divided by n square. So this sine square phi and cos square phi, when you add, you will get sine square phi plus cos square phi is equal to 1, isn't it? So that if you substitute here, you will get 1 is equal to 1 by n square, 1 is equal to 1 by n square plus 3 cos square phi by n square, 3 cos square phi by n square. So this, if you take this 1 by n square to the other side, so you will get n square minus 1 divided by n square is equal to 3 cos square phi divided by n square. N square and n square will get cancelled. So you get the relation cos square phi is equal to n square minus 1 divided by 3. So this is the relation. This is the angle phi. Okay, this is how you will find the angle phi, for which the deviation is, this is the angle phi. This is the angle phi for minimum deflection. Okay, for minimum deflection. All right. Now, if you take the value of n, the refractive index of water, as 4/3, and if you substitute here, you will get the phi value approximately. You will get the phi value as 59.3 degree. Okay, 59.3 degree. If you substitute the value of n as 4/3, which is the refractive index of water, in fact, the refractive index of water is 4/3 or 1.33. So when you substitute this value of n in this equation of, you will get the phi angle. Okay, the angle phi comes out to be 59.3. So this is the angle of incidence on the front face, for which the angle of deflection is minimum.